Good day everyone, I am Defeo from BSEd Science II. I am here to discuss about the important topic in electricity and magnetism. For today's video, I'm going to discuss about the topic entitled generator and alternator. But before that, I have a short video clip that is closely related to our topic. So, let us watch.
How do power stations provide electricity to thousands of houses around a city? They don't use giant batteries. They do that by spinning a giant turbine like this. And to spin such a turbine, some power stations use very hot steam that blows over the turbines and spins it. Or maybe we can use the energy of the falling water. Or another example could be, we fit these inside giant windmills and let the wind do the work for us. Whichever way you choose, all we do is spin a giant turbine. But how does turning something create electricity? Well, the technology is based on electromagnetic induction, discovered by Michael Faraday more than 200 years ago. The basic idea is that if you take a wire and move it up or down inside a magnetic field, it induces an electric current. So all we have to do is attach a coil of wire to these giant turbines and place them inside a magnetic field. As the turbine rotates, the coil starts rotating and the wires start moving up and down inside the magnetic field. That produces the electric current. And this can now be used to light up things. These devices are called electric generators. They convert spinning or mechanical energy into electrical energy. So let's look at them in detail.
Let us look a real sort of straightforward animation of how a simple AC generator works, and at first look might think this looks very much like the motor that we already look at, and that is because it's exactly like the motor, but rather than the motor being turned by an electric current. We're going to provide the movement and see if we can generate an electric current. So we've got a coil of wire in a magnetic field. Okay, now if the coil of wire in the magnetic field start to turn, so if we push it, because remember, with a generator or something could have to push the coil around, and if it is in a power station, it might be steam pushing it around, or if it's in some kind of waterfall, you might with a water pressure that is pushing it around, but something is pushing it around. So if we ever look when this coil rotates, we imagine it in this position. The arrow are showing you which way it is going around. We can see that the coil of wire cuts through the magnetic field lines, and as the coil cuts through the magnetic field lines, that exactly what creates the the electricity, or this is what induces the voltage, as we would say so, as it's cutting through on a little milliammeter here. Because we got a complete circuit, we would have a positive current. Okay, just to this in the fully working, you can see now that the coil is rotating, and as it goes one way, so if you imagine one side of the coil, as it cuts through the magnetic field lines, one way we get a positive current, and then it is cuts really other way, we get a negative current. And the maximum current is being produced. If you look at this graph of current, down here, the maximum current about now is when the coil is horizontal. Minimum, and it's while white horizontal is produces the most electricity, and even though I'm saying minimum and minus 100 amount of milliamps, then that is still obviously an amount of electricity. The note minus now the zero value. Now is when the current is when the coil is vertical. Now if you look at the graph and look here, and then the crosses the zero line, this is, if I stop it there you go, it's just heading towards zero. And then maximum when it is in horizontal, heading towards the zero, and then maximum. Okay, we already down about how a simple AC generator works. So for today's video, or for the second part of this video, the next questions we need to answer is, what is the difference between generators and alternators? But where is the difference on the same? Many people say the both of these things are similar and they both do the same thing. So generator and alternators is the same thing. Well, this is not incorrect at all because both of these machines are used to convert the mechanical energy into electrical energy, and both take the same thing amount or same power, that is mechanical power, and their primary work is to generate electricity. But where is the difference? The difference in the construction, there are certain differences in the second part of this video. The second part of this video, I'm going to discuss about the same. So here you can see that I have just completed up a chart. Okay, so here I have a written generator and here alternator in the both of these sections. I'm going to differentiate between them. The first difference basically for generator is that by generator, we mean a machine which generates the DC current. Okay, you have heard about the DC generator. So DC generator, it can also be an AC generator, which we called induction generator. Okay, or the AC generator, which is basically an induction motor which is working at a certain conditions where it generates electricity, while an alternate is only meant for generating AC current. There is no DC, okay? You can understand it by the fact that it's called alternator. You can see it is called alternator, so alt means alternating generator. It can be defined in like that manner. Okay, now let me wrap this up so that I can continue with the latter points. Okay. So, generator and alternator, the next thing that is really important apart from which machine generates AC and which mean generates DC. It is important to look at the construction. By general construction, a generator has something like this kind of figure. There are two magnetic poles which can be permanent or which can be electrically connected electromagnetics, or it can be permanent magnets. So you can say that this is the North Pole and this is the South Pole, and the field is stationary. The field or the magnetic field, which is there is a stationary, while there is a shaft which rotates and generates electricity. Okay, it is something like that. I'm sorry for my bad drawing up here. Okay, so this shaft is actually rotating in a certain direction. So the conductor, it carries off a conductor, and what we get, the electricity we get from this terminal rather. From here we get the electricity through brush and the slip ring and all those things. Sorry, commutators, not the slip rings actually. So we get electricity from here, plus, minus. Okay, so the magnetic field is stationary magnetic field. It is really stationary. It is stationary as it is standby one areas. The armature or the there is a rotating part of the conductor is what rotating, while in case of alternative the thing is different. An alternator basically looks like something like this. It's a kind of router you can see of an alternator. It looks like this one. This is the general trying given. It carries off a winding. This is called field winding. Okay, the field winding looks like this one. It's connected outside within the resources or with our exciter. And it rotates within the frame. Within the station, the stator or the stator frame, and this is rotating. Okay, and this is connected, of course, through brushes. So the exciter is there, and it has a certain polarity, not a whole south pole polarities, of course, of the router, and here remains on the stator, remains the stator conductor here. Here you can see the three phases conductors are there. So when this magnetic field is cut by this conductor, the electricity is generated in three phase. It's like this one, so there is a difference between both of these machines, while in case of generator, you can see that the field is stationary. The field is not moving, while the conductor, which is there for generating the electricity, which is responsible for output, is rotating, while the output wires are not rotating, or the output conductor is not rotating. The next differences is generator is bigger in size compared to alternator. Okay, generator or one another thing that is really important that has a really low weight. Sorry, it has a high weight per kilowatt output. That means the weight of machine for 1 kilowatt output is really greater than that of an alternator. Alternators basically used for, that's why this is recommended for high power output. Various generators is not that much use. If this is required or nowadays rectified, units are connected to alternators. Okay, one of the only exception you can see is the induction generator, which is not that much used. It is used in case of windmills. You can check it on the Google. Okay, so it is the only you can see the exception other than this. Alternator is only used in case of production of AC, while generator can actually produce DC or AC. But we can mean by generator that a machine which generates DC current basically. So moving to the next slide, basically you can make it note that generator means field remains stationary while the conductor is rotating. The conductor is the armature from which we are getting the output, while in case of an alternator, the conductor is stationary while the field is rotating one. Okay, that is the end of this video tutorial. I hope you learned something about it, especially our topic, generators and alternators, and importantly, the relationship between the electricity and magnetism. So I hope that it is very useful for you as a student, and thank you for your time in watching this video. Love you. Bye.